Hello everyone again. Welcome to the seventh stream. Hopefully you're enjoying the weekend, and as I do. And yeah, this time an idea is to cover Rust in details. Basically, I'll try to build infrastructure. I mean, the end goal is to build infrastructure for Rust query modules. So all the necessary abstractions to like build query modules as fast as possible. But yeah, initially, since I know almost zero about Rust, I mean, I did some stuff, but more or less nothing serious so far. I'll also spend a bunch of time today going through basically Rust resources and trying to figure out more details about Rust in general. And then at the end, I'll have some idea how to incorporate some of these learnings into the query module infrastructure. That's basically idea on a high level. And yeah, I've also did some initial code in the Mage repository. Actually, I've managed to compile Rust code and run it from Memgraph, which is already great, but it's basically empty for at this point. And yeah, I don't have a clear view what to build next. That will come throughout this video, hopefully. So yeah, this is gonna be more or less casual stuff, figuring out how to build the Rust query modules. And yeah, as always, feel free to ask questions in the chat. I'll try to address them as soon as possible. And yeah, if you like content like this, hit the subscribe button and yeah, share with your friends as well. Because this is going to take a long. I mean, this is going to be a much of explorations. In the first place, the whole video will take a bunch of time, probably a couple of hours. Probably this one is going to be the longest one, and also I won't manage to finish today like 100%. The whole Rust query modules thing will have a couple of parts for sure. Probably more than the PageRank thing. Okay, that's more or less it for now. I'll now jump into the code view and get started. Hopefully you can see. I'll try to position myself in the best possible corner. As always, maybe even cut myself off. But yeah, let's leave it like this for now. So as I mentioned, the query modules are already initialized, but I'll step back and talk about how to actually install Rust and how to do like basic stuff first. So let me go back to here. So this is my repository with all the setuping of the operating system and stuff like that. So actually, here I have a script. Here I have a script that does installation. But yeah, basically, I'll just maybe a better way of showing this would be to just go to the website and install things. So here it's a very nice one-line command to install Rust on your system. That's gonna work on macOS and Linux. So on Windows, I think you should do something else, but yeah, you should figure that out. I won't cover that now. And And yeah, basically Rust up is, so in order to install Rust, the recommended way is to install Rust up, and that's basically some management tool to install the whole environment. But with Rust, when you install Rust up, there are also Rust C and Cargo, and Rust C is obviously the compiler, which is going to be used to compile the Rust code, and the Cargo is a package manager. So, and yeah, from my experience in general, like from my little experience, like Cargo is really amazing. Has a bunch of things embedded inside it, so it's a really powerful tool and can be used for a bunch of stuff. Basically, that's it, and I'll just go back here, and this is my setuping script, so I'll just remove the thing. I'll just do this. Okay, and now I'll just rerun that. Basically, that will run the sudo, that will run the installation of Rust, and so this is the script which is running now. So what that's gonna do, that will create these folders, Rust up in home folder and Cargo, and also Cargo and Rust, Cargo, Rust up, and Rust will binaries will be placed here, and it will also modify the environment files to have environment properly set up when you start your machine. And to not complex now, I'll just hit 1, which is a default option, and that should install. Yeah, since I already, it takes some time initially to download all the binaries and all the necessary things, but since I've already done that, it obviously use some type of cache or something initially. So so basically that's it. Let me just revert this because I can reuse this script to install things. So that's it for now. And basically now we have installation of Rust. So as I mentioned, there are 3 tools. So Rust up, that's one tool, and it's version 1.23, and it says that Rust C is the actual compiler. Yeah, and Rust C, and that's version 1.5, which is pretty recent. And yeah, that's also a really good thing. So Rust has a pretty fast release cycle. Like every 6 weeks they have a new version, which is also really great. So basically I have a compiler from a couple of days ago, not that old. And also we have Rust up, Rust C, and Cargo, and that's also version 1.5. So Rust C and Cargo comes with the same, even though it's not exactly the same. Versions like dates are a bit different, but yeah, that's fine. So the Rust is successfully installed now, and just to check that everything is working, I'll just go to the mage repo and try to compile things with that super quick. So let's say build this, and if I understood correctly, Rust puts everything into the target folder. So I'll remove the target folder for now, and I will explain this later, but the cargo toml file is used to specify dependencies and build details. But to actually run the build, you just have to run cargo build, Mm. Oh, I did a super stupid things here. Okay. I actually removed the entire folder. That was a stupid mistake. But yeah, now I have everything here. And if we run cargo build, that's gonna build the project. So that's a default command to run the building process for each Rust project. I think it's pretty standardized. All right, that's about it. Okay, and yeah, since everything is working, I will. Maybe I can just showcase that the thing is actually working. So if I ls target, there is a debug folder, and because that's like a debug build, but here in the debug folder we actually have the SO file, the dynamic query module, dynamic library, which is a query module, and let's just run that. So I've prepared the command here, so that will basically map target debug folder into the query modules folder within Memgraph Docker container, and run the whole thing. So if I run this, it has these a couple of unknown files, but essentially it says loaded module. So module is here, and let me quickly check that through the lab. If I go here and I run the procedures, there is a test procedure. So libtest rs query module test procedure, and it has this signature. So I'll just call to run that, even though it's completely empty. So, but I'll just run so that we can see that everything is working. Okay, and no data found because nothing is returned. But if we go back to logs, it says run call that procedure, which is great. Okay, okay, and then I can jump back and just explain what we have here. Basically, yeah, I'll have to explain all this into more details, but basically in the major repository, there is the procedure mgprocedure.h file, which has all the declarations of functions and structs in C. And what's the idea? The idea is to build based on that. I mean, the idea is to build bindings for all these functionalities here. And what's really nice about Rust is that they have a bindgen library that this one here, that can scan a header file in C, and it automatically builds these bindings. So it essentially builds the mapping between the C functionalities and some kind of Rust constructs. So it's very the whole code is very raw, and mapping is very simple, and it's not something that it's super easy to use, but it works. So it can be used and like to build anything you want, but it's not easy to use. And essentially we're using that bindgen library to generate these bindings. And let me just showcase. So to build that, I'm going a bit into the rabbit hole but I'll go back. So to build these bindings, a preferred way is to build a build script, and then essentially whenever the header file changes, that script will pick up the changes and we'll regenerate these bindings. And this is done inside this file. It's very simple. So it just says Cargo has already built-in functionalities to detect changes. And then it's just calling the actual parsing and the generation of these bindings. And it stores the binding rs file into the, so that's here, into the output directory, and that's somewhere here. I'm not actually sure where exactly. I think here, or maybe here. Nope. Yeah, it's here. So Rust has, I don't understand the whole build process at this point, but I found this file here, and yeah, it has a bunch of these functions and everything generated. But let me find something familiar. Yeah, this here. So for example, a function mgp alloc is here, and it's actually the binding actually picked up the documentation as well, which is great. And so for essentially for each function from the header file, it's generated a function here and assigned types that are like known to Rust. So yeah, for example, here the mgp alloc returns nothing. No, it returns pointer to void pointer, and here that's kind of type of void pointer that Rust understands, and that's more or less done with everything else. I won't go into details now, probably later, since we'll build wrappers for all this, so we'll have to understand each thing, each call in a very detailed way. So okay, that's about it, and let's unwind the stack. If we go back here, essentially what we did, we just included that bindings file, include some of the Rust types. FFI is foreign function interface, so it's when you that's like a term used for if you call stuff from other languages. So in this case, we are calling functionalities from the C, and then Rust has these types which could be used for call functionalities in other languages. And let me go a little bit down. So what we actually need is create these two functions. So mgp init module and mgp shutdown module. These two are used from within Memgraph to initialize the module. So once the module dynamic library is loaded in the runtime, these two the first function is called mgp init module is called, and then that function is initializing the whole module. And here we built a function in Rust that is compatible with that. Like once we built a dynamic library, a function with this symbol, with exactly this symbol, will be in that dynamic library. And yeah, so by doing this, and then by running the read procedure module add read procedure, we added test procedure call, test procedure in the whole module. And that's it in order to load the module. I'll get back to all of this, but I just wanted to present that this thing is actually doable. And since I've basically hacked this together super quickly and super dirty, I'll go back and explore more about Rust, and then maybe I get some ideas on how to expand and how to improve. All right, so a little bit of setup. Let's close this. We don't need this for now. What's this? We don't need this anymore. And the whole code is already in the Mage, so the thing that I just explained is already a pull request in the Mage repository. So that's great. I also have this educational repository on my GitHub profile. So the whole code that I'm doing right now will end up there. Since this is not useful code, this is just for the educational purposes. I'll just upload that there. And also, what we're gonna do in the majority of time today, I've collected a couple of interesting resources about Rust and put it in the livestream repository. And essentially, this is huge. Like the whole resources here have a bunch of stuff, but I think this link here is probably the biggest resource when it comes to value cost to benefit, or it has a bunch of stuff built in, and we're gonna just go through all of that. So this is a blog post, a half hour to learn Rust from a guy called Amos. So yeah, thank you, Amos, for assembling this together. I'll use this to learn more about Rust, and then maybe use some of these things to build the actual query module. Okay, and just a little bit overview here. So my goal is to cover the first link, the second two links, the other links are super huge. So this is like the whole book about Rust, and it's huge. I don't think I try to cover this by myself, and then just pinpoint the most interesting things in the following streams, and also the huge documentation on the Rust page, so which is also amazing, but it has a bunch of stuff. And yeah, actually Rust has a pretty good documentation in terms of everything from my perspective. So we're gonna use that heavily, 100%. But yeah, and then in the stage 2, let's say, these are more specific things and more specific advices like error handling and ownership. Rust ownership, that's a big thing in the Rust ecosystem. That's one of the probably most important things that Rust brings, and which simplifies a bunch of stuff and prevents programmers from making silly mistakes when dealing with the memory. All right. I'll close this for now, and this. Let's get here. I'll try to split my screen like this, and yeah, I'll try to move myself somewhere, let's say here, since majority of the time I'll spend here, and maybe put this here. Yeah, yeah, okay, should be good now. Okay, let me go to the education part. So okay, this is I've created a folder, a file for experimenting with Rust, and then I'll go through all of that. So basically, let's say Rust code. So let introduce a variable binding. Yeah, that makes sense. So when you say let x, that will create a variable x, and then you can assign value. So I'll just try to do this. And then obviously there are multiple ways of doing that, but let me just try this. And if I run here, and yeah, obviously if I run, so since I don't have the cargo file here, I'll just run pure like Rust compiler to compile. And now this is not visible. I'll try to put myself here. Anyway, and then have everything on the upper part, in the upper part, which is good. Okay, so Rust C, how far? Boom. So that's an error. Found keyword. What's the wrong here? Okay. Let me just try to compile an empty file. Consider adding. So considering adding a main function to. So we need a main function similar to the C. Yep. Okay, and just main. Okay, so the syntax for that is fn. That's probably function. That's like a function main, and then this, and then let's move it here. Okay. Okay, now we only have a warning which says unused variable x, which is great. Okay, that's good. But as we can see here, we can print variable by running println. Okay, that should work. Yep. Half an hour Rust. Boom. 42. Yeah, that's correct. Great. But if I go here, let's say Rust C -- help. What the compiler actually has from the perspective of flags. So help L add a directory to the library search path. Okay, that we don't need now. L is not that we don't need that as well. File name, write output to file name. Yeah, that's something useful. We can rename the output binary, some flags, and yeah, basically let's just do that. So half an hour Rust, and then let's say Rust C minus O. I know. Let's say a dot out. That's like standard default in GCC. Bomb. Haha. Okay. That's okay. Let's go back. We hacked a bit the whole thing. So yeah, you can specify the variable types explicitly with semicolon. That's type annotation. Colon. Okay. What if I do that? So x 32 That's fine. But what if I say boom? Expected. Oh yeah, so it's checking the type, which is great as well. So let's go back. 42. Okay. Signed 32-bit integer. There is I8, 16. Oh, even the 1 to 8. Interesting. And unsigned variable variants of that, which is great. Okay. Single line. Yeah, that's fine. If you declare a name and initialize it later, the compiler will prevent from using it before it initialized. Yeah, that makes sense. But yeah, actually, like other languages won't prevent you from doing this. So, but where is the function? We have to create some function. Let's say fn foo bar x. This should be enough, maybe. And if we do let y, boom, expected. This is now some kind of an error with types, probably. No. Type name. Let's try to do type I32. What's gonna happen now? This is intentional prerequisite unused variable. Okay, so it seems that the Rust is ignoring unused variables if you put underscore there. Okay. If this is yeah, but now use of possibly uninitialized y. Yeah. That's now the correct error. So we have to initialize that by putting here I32, let's say 100. Now it should work. Yeah, but let's do something meaningful here. Like, I don't know, dummy print. And then move this here. So print x, and x won't be unused anymore. Okay. Dummy print y. So that should print. So like we're gonna compile with this, and then also chain and just call this. So okay. X is now unused from the main, but let's ignore that, and there is print here. Great. Okay. This means, yeah, we did that. Throw away something. Yes. That's similar to Python. So if you just specify underscore, that will ignore the return, the value. Okay. Names that start with an underscore recognize just compiler. Okay. But our code is working in progress, and we just wanted to get rid of compiler. So yeah, if we just want to get rid of here, we can also do underscore x here, and that will now work. Okay, makes sense. Yeah, even though I see this can end up very badly by having a bunch of underscore variables that are not used. But yeah, compiler can pretty efficient. I mean, like 100% efficiently optimize that. So that's not a big problem. Separate bindings with the name can be used shadow or variable binding. we can have multiple x. Interesting. So if we do this and then let x, let's say 101, what's gonna happen with this? Okay, but it actually works. Let's print the variable here. Yep. It's just to make it more clear. Yep, it works. All right. Great. So yeah, actually that's a bit different from, let's say, C++. Like you can't have multiple. You can define variable. You can declare a variable multiple times. This is a bit different. So it overrides the previous variable, which is, well, okay. Rust has tuples which can think of fixed length collected values of different types. So yeah, tuples are like in all, this is very similar to Python code as well, at least from my perspective. Let pair equal a and 12. Interesting. This is an interesting syntax. So dummy print, let's say a dot pair dot 0. Nope, not gonna work. Hey, we have the first problem. So that's why I called dummy print, since I can't print char, and this is a char. But yeah, let's replace it with, I don't know, 10 for now, just to be able to. Yeah, that's okay. That's okay. I want to annotate a type pair. You can also annotate stuff. So pair, let's say I32, I32. What's gonna happen if I do I64? Nothing, probably. Found you can't convert and panic if the converted value doesn't fit. Interesting. So yeah. If so, I can try to convert with this function, try into, and then if conversion fails, then that's gonna fail. Okay, let's try that. Try into unwrap. So here, try into, yeah, and then unwrap. So that should work, since method not found in I have to do this is very nice. So compiler actually tells you what you should do. So probably I should do this here. I have to include that somehow. Boom. Yeah, okay. That's amazing, but let's try to break it. So I think 32 bits integer overflows after like a 4 billion or something like that. So let's try to put like 10 billion here. 1, 1, 2, 3, 1, 2, 3, 1, 2, 3. That should be 10 billion. Boom. Okay, now we have a panic. So thread main panicked at called unwrap. So this is very nice because like even if you make that kind of mistake, the program is gonna explode, which is a good thing, a very good thing, because you can then fix and detect an issue that would in C++ that would go through easily. I mean, you have to build your own your own checks and stuff like that, but here that's built in, which is great. All right. Okay, now I again deviate a bit. Yeah, it says the thing is half an hour. But yeah, I already spent a bunch of time, and I did like 10%. So yeah, lol. We're gonna spend much more time here. Okay. What else? That's good. That's good. That's good. I'll leave that code as is. I'll just do a bit. Yeah. Good. Okay. Annotations, we did that. Tuples can be deconstructed when doing an assignment, which means they are broken down into their individual fields. Yeah, that's similar to, that's the same to Python. So let AB equals to what to pair. What about this? This should work. And then if I print A and B, what? I've changed. Have I saved this? Aha. No. Aha. Sorry. I did the same mistake here. Let's just print A and B will unused. Yeah, but okay. Okay. Yeah, so I did the same mistake with the dummy print. I think I should really the dummy print doesn't make any sense in general, but yeah, we'll deal with that later. This is especially useful when a function returns a tuple. Left, right. What is that? That's like any arbitrary function. Yeah, we don't have. Yeah, so this, okay, that's like a function that returns two values or a tuple that will be split into two parts, left and right. And you can ignore the same thing, yeah, as above. Okay, that's fine. I won't do that here. Semicolon marks an end of the statement, yes, which means statements can span multiple lines. Obviously, yeah. Let me actually copy this code. This might be interesting to explore. And yeah, now we have problems with the formatting. But that's kind of right format. So let X, we have a vector, an array of numbers. We iterate through all of them. We map, I assume this is initial variable, and then basically we add 3 to each item in the vector and fold. What is fold? And yeah, it would be nice to know, but I don't have a setup for that. It would be nice to know what the fold does. It probably aggregates everything. So, but yeah, let just, what's gonna happen here? $60. So if we add 3 to, yeah, that might be true. So fold is like aggregate aggregate. So 0 is probably the starting point, and then the two variables are x and y. Probably the first and the last one, and then but I'm now making assumptions. We'll come to that later probably. Let me Google. An iterator method that applies a function producing a single final value. The initial value is the value of accumulator. Yeah. This is like accumulator. After applying this closure to every element of the iterator, fold returns the accumulator. Yeah, this operation is called reduce. Yeah, reduce function. Okay, fold is a reduce. Yeah. So I think I'm not sure which one is what, but x is the previous value and y is the value from an array. So it will just make the sum of the entire array. Okay. Actual mean fn declares a function. Yeah, we figured that out already. Void function, yeah, and here is a function returns 32-bit designed integer. Okay. So this is actually a return value of a function. If we do here i32, that's gonna fail probably because I'm not returning anything. But if I do like 10 here, and that's also interesting. So Rust is, you don't have to specify return here, you just write 10, but notice here we don't have semicolon. So if we do here, yeah, that's fine. If we add a semicolon here, flump, turn, it doesn't have a return expression, but we can, what if we do this? Okay, so yeah, you can do return 10 semicolon, and that's like explicit return, and that's like a shortened version. Okay, yeah, makes sense. Okay, a pair of brackets declares a block. Yeah, as in other languages as well. Most of the, or I don't know, I'm actually not sure about, some of them don't have these kernel braces. But yeah, fine. A block of code. This is different text. Yeah, makes sense. You print this and this, you're gonna get two different values, which is fine. Blocks are also expressions, which mean they evaluate to a value. Oh, that's interesting. So each block is an expression. That's nice, because you can probably do nice things here, but fine. Inside the block there can be multiple statements. First, second. This is like kinda, like a function, so it's an anonymous function here that gets executed. That's nice. Y plus z. Bum. Nice. All right. So yeah, it's actually the whole block got evaluated, and the function, the return value is 3. So yeah, and that's why I'm omitting the semicolon in function. Yeah, that's what we already did. Good. If conditions are also expressions. Match. Okay, so now we have feeling lucky. If feeling lucky 6, else F4. Okay. What do we do here? Fair dice roll. Okay. The whole block is an expression, and it will get evaluated. Something from these things will be, something from these values will be eventually, I don't know how to yield it. A match is also an expression. Yeah, I don't understand. I noticed match, but I cannot say I understand the match in general as a construct. So, and all the implications. Let's Google that a bit. Rust provides better matching via the match keyword, which can be used like a C switch. The first match arm is evaluated and all possible values must be covered. Match number. And then if one. Okay, if one, then print. If 2 or 3 or 5 or 7 or 11, print. What is this? A teen. Everything from 13 to 19. This is kind of weird. And then for everything else, do this. Okay. All right. So instead of doing I'll try to do like flip function. That accepts x. How to say boolean? No. So it's bool. Match x. If true, then return false. If false, true. Okay, then that makes sense. Now we are slightly inconsistent with this. Okay. Dummy print. I'm all really annoyed with this dummy print. I'll try to. So in other languages there are templates. So the problem with this here is that I can't use this for printing anything else than an integer of 32 bits integer. So simple, write a simple. Let me do this. Okay, how to do that? C++ Rust. Bum. Okay, attempt one template this. Well, this is bad. First so you better refer to documentation. La 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 la. This is some these are some type of, these are some constraints. No. Let's go to the legit documentation. That's usually much better than doing Stack Overflow. For example, defining a generic function named foo that takes an array of type because it has specified as generic. Okay, so okay. So if I do here like a t and then do here t and then let's return 0. Okay, let me now call this so flip dummy. I'm still probably dummy print, since there is print ln exclamation mark something that probably has a bunch of other stuff included, so I'll still call my function dummy print, but let's call here flip from false of false, so that should print true at the end. Nope, this method resolves to proof. Okay, this is something completely, I have a bunch of errors here. Expected match no. T can't be this is I need like a format there, but what is the display? Like that. Match. What did I do here? Try. Return type. Okay, only one error. This method call resolves to result. Try into something. Cannot infer type for type parameter t. This is some kind of, it's not, this is not. What if I do let p equals will I still have the result? That will be unpacked. Okay, so yeah, this the unwrap returns some kind of packed type, which is a result, and then when I assigned it to the 32-bit integer, then it's converted, then it's automatically converted. So something like I maybe I'm saying something wrong now, but yeah. But to long story short, we have a flip function that works, since we are sending false into flip function and then we print that and we got true. Plus we have a generic dummy print function, which is a great success. Okay, again, rollback. We did a bit more than expected here, so that's okay. But yeah, let's go back on the track. Dots are typically used to access fields of a value. What is that? Aha, okay, that's the same. That's kinda super intuitive. But yeah, 0 is kind of a special syntax for pairs. Or maybe for other stuff as well, but I don't know. And then we have this, which is fine. Maybe I have to check. So, yeah, feel free to ask questions if you have one. This is, I think, pretty basic, but yeah, feel free. Call a method. So let nick equals and if we print nick dot what len, yeah, 4, yeah, that works. So we could just call the function. So that's nick is probably a string or something like that. What if I put this here? Flomp, it's not a string, it's string reference, and I have to convert it to a string. And what's gonna happen if I do that? Oh, sorry. Boom. Now we have move occur. So nick. Now this is why Rust is interesting. So borrow of moved value. Yeah. So dummy print moves the value of nick. So the whole string is the string is moved, and then we use that in order string is moved into that dummy print function, and then after we use that the same reference, I mean the same object. I don't know. Maybe I'm not 100% correct in the wording, but we use that object later, which was moved before, and that's wrong. So that's what Rust is trying to prevent from doing. So this is not gonna fly. But there is also another option. What if we do let nick of str? Oh, what's gonna happen here? That's gonna work. Okay, so yeah, what's the difference between a string and a ref string? Yeah, that's more or less the question. Is the dynamically heap string like vec used it when you need to own or modify your string? Is immutable sequence of okay, a reference to some string slice or just slice. A slice is just that's like a string view in C++ or something equivalent to that. Basically, okay, but basically, yeah, a string is a dynamically allocated object on the heap, and str is like a static object, probably somewhere in the somewhere in the memory, and ref string is a reference to that, or a slice, if that's the right terminology. Okay, that's good. This is example is a create. Now we double colon is just referencing the namespaces. Okay, so that's again very similar to C++. So in order to navigate through these namespaces are probably like just a chunk of code, code that is named together, and in order to navigate them, you need these double colons, which is good. And then we have some standard. So we have STDs, stands for like a standard namespace, and then CMP is compare. So standard compare, and then give me minimum. So yeah, let's try that. Let list std cmp min 38. Fuck. Yep, that's worked. So I've got 3 here, which is minimum out of 3 and 8. Okay. Use directives can be used to bring in scope names from other namespace. So yeah, that's also a known thing. So if we use, can we do that here? So use std cmp min. So we should be able to remove this. Yeah. So that probably has some disadvantages as in the C++, or maybe it's implemented better here, but yeah, it's usually we actually just included min here, which is good. What if we do cmp? That's gonna fail because unused import cmp and then but we should be able to do this. Yeah, okay. Let's put it back. Okay. What if we define, what if we do let min equals? Haha. What if we do min here? Cannot, yeah, okay, functions can't be okay, but if I move this here, this should now work. Yeah, but if I do this, yeah, so this is is not great because I've called my variable min in the same way I just use this min thing here, and then I override the variable, the type, and that's gonna produce an error because min is not anymore a function. It's a variable now and can't be called like that. So that's why usually it makes sense not to use this. Override min. Instead of using this, I think it's wiser to use this because there is no chance of doing this error. All right. That's like mean. Okay. La la la. We didn't use directives. Curly brackets have another meaning. Nice. Dada. Yeah, but this is kind of nice, but yeah, doesn't mean a lot. In general, I think we should prefer using std cmp, but yeah, maybe there is some other standard guideline or something. In any case, yeah, this is nice as well. If this is a preferred way, then great. Import everything. Yeah, that's also fine. There are namespaces too, and methods can be called as regular functions. strlen. Okay. str is a primitive type, but many non-primitive types are also in the scope by default. What? Okay. Vector. This vector is in the scope by default. Yeah, this is obviously a preferred way. So yeah, okay. Great. This works because Rust inserts this at the beginning of every module. So that's done by yeah. So if people in the Rust community are using that, then that's fine. Okay, obviously that's not that big of a problem. So we have vect string option and result. Struct keyword. Okay. Okay, let's do this. Now becomes a little bit ugly, but I'll continue using that for now. Struct I'll call it dummyvec. X is float 64 and Y is float 64 as well. Obviously we can have comma at the end, which is also nice. We can initialize that. Amazing. So let v1 equals vec dummyvec x equals 1.0, y equals 2.0. Okay, what if we print yeah, we can't format that, but what's gonna happen if I do 0 here? No, only pair has the 0, so we have to use x here. Yeah, okay, makes sense. All right, this is shortcut. What? For rest of the fields. Oh, what's gonna happen here? I assume y is gonna be 2. X is let's be precise. So y is 3 and y is 2. 1, 2, 3, 4. Okay. And if I do let v3 equals dummy vec x equals 14 and then dot dot v2. Okay. And what is v3 dot x? I assume y should be 2. Yep. Nice. Not bad. Yeah, that makes sense probably only if you have plenty of these struct variables, struct properties, or how to call them, and then you want to, I don't know, change one and use the rest. So in that makes sense. In that case, it makes sense to use something like this. Struct update syntax. So this here is called struct update syntax. Okay. Can only happen in last position and cannot be followed by a comma. Aha. So this is not the same. So we can have, it should be exactly like this. Now the rest of this can mean all the fields. Okay. Struct like tuples can be destructed. This is kind of misleading because destruction means like deletion or something, but this is destructured. Sorry, destructured. Yeah, that's fine. Just like this is a valid let pattern. Yeah. So is this bum? Okay, makes sense. And this. Throws away. What? So let vec2 x I don't understand this part. So if I say let but this is a very different. No, we skipped this part here. So let vec2 xy equals v. Why do you need to say this? Let me copy this exactly like it is specified. Okay. And But what does x is now 3, y is now 6. This is some kind of like a structural saying that these two x and y are from dummy vector, or what? I have to be honest, I don't quite understand what would be the purpose of this. I mean, obviously x becomes like these things are assigned, but why do you need to put if we what if we do here? That's gonna probably explode. Yeah, this is tuple. This is kind again like a special syntax. This is again a special syntax that tells that knows how to reconstruct these things. Yeah. Okay. But how is this called? Like it doesn't say. Yeah, I don't know. There has to be a term for this concept that has to be named somehow. Okay. And then if this throws away, okay, yeah, that makes sense. So the same, just, but why? What about let dummy vec? Why not use this here? Because that should throw away. Let's just x. Now we might end up in the wrong spot. So expected identifier found reserved identifier. Okay. Yeah, but what if I say here like z? What's gonna do that? Yeah, this has to be completely. That's why there is a different syntax, because underscore means something else, and like this because it searches for the exact same name, so underscore doesn't exist in the v variable, so you can't map it. But once you do that, you immediately have in the local scope x and y, and that's related, but yeah, I mean dependent on the actual. How is that called? That's like super interesting. How is that called in general? I'm not sure. Probably we'll learn at some point later in the future. Okay, I understand. I hope you guys also understand the concept. It's pretty simple, but yeah, a little bit cryptic, because it's specific. So you need to specify the type, even though it's not like specifying, for example, type here with colon. It's not that. So you have to specify a type, and then you can create local variables that has the same name as the type, like the properties in the struct, and basically you can just assign the value from that variable to them. Yeah, interesting. That works. Okay. I have a bunch of these. I'll just clean a bit. xp nick x. Nope. Which line is that? 23. This x is not used. And 34. And this b is not used. Okay. Okay, well, let's continue. Where are we now? Still no questions. Good. Let patterns can be used as a conditions in if. Okay, struct odd value. Assignment print number. Okay, print number is magically here. Print number is here. Number. If let number. I see now. This is a useful. This is a useful construct. So, because you can create these local variables which have exactly the same name, odd and value, within the if. Let patterns. That's the name. So let me go here, and this is called let. Okay. Main let number. Okay. Let me copy this completely. Main, we're gonna move that there. We are also inconsistent here, but fine. So let number odd value. If let number odd value. But this has more than just unpacking. So if odd is true, then print value. If odd is false, yeah, this is super packed. I like that. So it's nice that you can specify these values as well. All right, let me just here do a little bit of formatting. Yeah, that's why. We're gonna do that manually, automatically later. Okay, what? So if true, then print odd number. If false, then print. If I change this to false, it should it should work in the wrong way because the interpretation in the function is wrong. Nice. Okay. Let's move on. Yeah. Half an hour is not the case. We are still almost at the beginning. Okay. Print. Okay, now this is that's getting interesting. So print number okay, let's figure out first what is going on. So match, if I match a number which has odd set to true, then I map value and value is printed here. Yeah, this is just a nice way of implementing the same thing. So I'll leave it as a comment here. Sorry. No. Okay. This should produce the same result. Yep. Okay. Yeah, I print this. I think this is pretty straightforward. Nothing crazy. Okay. And yeah, now these nice things are used here. So since I have some problems with my, let me fix the, okay, sorry, I have issues with my mic. Mic almost dropped from the table, so it should be fine now. So let's get back. Here, if the value is 1, then do this, ignore everything else. And in case, yeah, this is basically for values 1 and 2, we do specific thing, and then for everything else we just print the value. If that last arm didn't exist, we would get a compile time error. Yep, makes sense, because let's check what's the compile error. So patterns number value min and number not covered. Yeah. Rust compiler is super clever here. So it actually checks that all the values are covered in the one, two. If we do odd true, boom. Okay, field is never what? What's that? Where is that? 23. Oh, sorry, that's a vim command. Yeah, very nice. So Rust actually knows that odd is not used. No. Where did I to? Odd is never read. But that we can't solve by that. we should unpack. This should fix now. Yeah. Okay. If that's hard, underscore can be used as a catch-all pattern. What's that? Aha. Yeah, okay, that makes sense. That's I think this is very intuitive, because like if you match one, then print one. If you match two, print two. If you match like whatever, then print value. And yeah, n can be used here, n dot value. Since we don't have a let pattern here, then n has to be referenced and then value will be printed, which makes total sense. Okay. You can declare methods on your own. Okay, let's make a quick break here. I'll just go and make coffee, and then I'll be back super soon. So I'll be back in a couple of minutes. I'm back. Oh, someone is still watching. So great. Feel free to ask questions. I've made my coffee. It looks like Guinness, but it's not. It's it's a regular coffee. So yeah. Let's move on. Where did we stop? Print number. Okay. Struct number. Struct number. Oh, la la la. Now we have some interesting thing. You can declare methods on your own types. Okay, we can add some method on a struct. That sounds interesting. Okay, a number. Here we are. Implementation number. fn is positive self bool. So I have to initialize my Vim setup, but let's ignore it for now. Self dot value bigger than 0. So this is a bit this requires a little bit of explanation, I think, because so I assume by saying implementation number, we are specifying the implementation details of that number, and then we just specify a function which is called is strictly positive, and self, that's again very similar to Python. So self will be a variable where, I don't know, a pointer or reference or something will be stored to that exact object that has these values, odd and value. So self is just a reference, some kind of a reference to the actual data, and then the function return bool, and then this, as there is, and as there was explained before, self dot value bigger than 0 is an expression, and this will be evaluated to a boolean, and that value will be returned from the function. Yeah, so this is super convenient and super clear, I think. So I think we should be able to call that function on a number by our dummy print one dot is strictly positive, and I think we should get true. Again, the same issue with Rust. I don't know how to avoid it. I should probably do some kind of copying or something in order to avoid the issue, but for now I'll just comment this and that should work. Yeah, true. So we got true for that. And if we put here -1, we should get false. Yeah, okay, that makes sense. And use them like usual. La la la. Okay. Bum bum bum. Okay. False. Odd. False. Value -2. Yeah, makes sense. That's fine. Value bindings are immutable by default, which means their iterator can't be mutated. Value bindings. Value bindings. So I can't mute, if I do let n, I can't mutate n, which is okay, makes sense. I mean, makes sense. That's similar, I think, to... No, it's not. JavaScript has a const, so it's not n equals number, la la la. And we cannot assign twice to immutable variable n, and yeah, n is also, so n is immutable and these values are immutable, so everything is immutable. And then if we want to make that mutable, we should add like mute. That's like mutable, okay, and dot value equals 1. Dummy print this. What is going on now? Again, problem with move, but actually we have slightly different error message now. one move due to this method call, value partially assigned here after move. Aha. Which does not implement the copy trait. Aha. And traits are explained here. So traits are something multiple types have in common. Okay, trait signed. Trait is some kind of an interface or something. Probably not, but that's probably the closest equivalent. You can implement one of your traits on anyone's type, anyone's trait on one type of. Okay, but not a foreign trait on a foreign type. Okay, this is a bit cryptic now, but okay. These are called orphan rules. Poof. A bunch of interesting stuff here. Here is an implementation of our trait on our type. So implementation signed for number. That's the same as So trait is signed, and then you are implementing that trait for that type number. Okay. Let's just copy that to not type all these things. It should be the same. More errors. Not a member of trait signed. Because I am okay. Yeah. So impl of number has these. So that's implementation of is strictly positive, and then we have a signed trait is strictly negative, but then we need to implement that. So 1, 2, 3. Value equals less than 0. Okay. And what about this? That should compile now, but let's avoid these issues. Yeah. Sorry, that's my mistake, because I forgot that the last expression should be okay. Okay, and we got a warning that one is mutated, is marked as mute, but it's not mutated throughout the code, which is again nice. A nice warning. Amazing. Okay. Is strictly negative. We did that. Yes. Okay. Our trait on a foreign type. Foreign type is something we didn't define. So, and then let's go back here. One of your traits on anyone's type animal trait but not a foreign trait on a foreign type. Aha. So you can't like take a trait and implement it, take a foreign trait and implement it somewhere else on the foreign type. But anyway, I think that's not critical. A foreign trait on your type. So obviously negative is a trait used to overload minus the unary minus operator. Okay, for number type output equal number. What is type? A foreign trait on our type. Okay. That's one more thing to implement. Implement std ops negative number. Okay. If I just do fn neg self, that will return. Aha, that will return number. Okay, yeah. Number value minus self dot value. Okay, and if I have odd, okay, I have to close this. I think I should set up formatting as soon as possible. Okay, but now this, I think that's gonna massively failed because output. Yeah, I think I understand what's the output here, because that trait neg has an output type, and that type, since we are implementing the trait, we have to also specify what's the output type. In our case, that's number, and like that has to be injected because like we have to alter the trait. So equals number. Yeah, that's compiled now, but let's actually call that. So we have neg. So if I, to avoid the borrowing and these issues, I'll just create another variable, which is for false, and here is 4. And I think negative should invert the value, but that's gonna fail because a local variable with a similar name. Sorry. Not found in number, method not found in number. Why not? Since I've implemented that. At least I think I did. Sorry. It's not that we don't have to call, we just have to put this. Yeah, and now, and what if I say I have to take value out. Bum. Okay. It actually works pretty good. So amazing. So here we have a number 4. We prefixed it with minus, which will actually call the implementation of neg trait, and then we extract value and print that. Amazing. Okay. I think we covered all this, which is great as well. An implementation block is always for a type. So instead of that block self means that type. Aha. Aha. Nice. So if I replace here self, that will mean number. So the output should be exactly the same. Yeah. Okay. So here self means that type. Okay, makes sense. Some traits are markers. They don't say that a type implement some methods. They say that certain things can be done with a type. Okay, for example, implements copy trait in short is copy. Okay, so this works. Copy. Okay, and this also works. Print is copied again. So we need a copy. But the number strict is not copy, so this doesn't work. Yes, that's the same issue. That's now issue that we had with moving and Rust in general. So we should implement a copy, and neither does this. Yeah, okay. Yeah. Fine. Is borrowed from the but it works if print number takes an immutable reference. Okay, so instead of, so if we print 1 here, if we print 1 here, that's gonna fail. Okay, mute can stay, but 1 dot value equals 1, and then if we take a reference, so this is immutable reference to 1, that is that yes. So it's a mutable reference. 1. What's gonna happen here? Now the problem is we have to take a reference. Okay, print number. So we have to specify a reference here. But we have to adjust the code. Sorry. What's gonna happen to the last call? Not that's dummy print. And 1. But if I do, I think this shouldn't work because 1 is moved here. And if I remove this, no, what about the reference? Yeah, so value borrowed after move. Yeah. So that's not gonna fly since we do this here, but we can't just put a reference here because the initial function is like the dummy function doesn't accept the reference. Okay. But we can print like again the 3. So for example, that should work. Yeah. Okay. Okay, so now we have more stuff. So we have move. We can do move, and we can also take a reference, or more strictly speaking, we can borrow n for the duration of that function call. Okay. It also works if a function makes mutable reference, okay, but only if our variable binding is also mute. Invert. Yeah, if we take a mutable reference to the number, we also have to say that here, that we are taking a mutable reference, so everything is explicit. So yeah, let's add that as a function. So fn invert and mute number. Okay. N dot value equals n minus n dot value. And now this function does not return anything, and it has the semicolon at the end, so should be fine. And then in order to do that, let's do what's gonna happen here if I say invert. So mutable reference for, that's gonna fail, I think. Cannot borrow as mutable. What? Cannot borrow as mutable. So if a variable is not defined as a mutable, you can't do okay. Invert, but wait. If I do dummy print again, now this should be fine. Sorry. My bad. Yeah, okay. So I think here this is possible because if I do here, if I just print number 4, I think everything is gonna collapse. Because I now have that. Okay, a reference is here, so it's not possible. We need another. What? Let's do that. So if I say that I also have function print number that takes number, what's gonna what's gonna happen here. Okay, we can't have print number multiple times, so there is no, maybe that's a wrong conclusion, but it seems there is no function overload concept. And maybe that's because the numbers, the argument is actually almost the same type. But in any case, print number ref. Let's make it explicit, and then la 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 la, and ref. We need to add a ref here on every single call where the ref is used, and then print number 4. I think that's gonna collapse now. Yeah, values here are okay. Yeah. But what I wanted to say here, that was obvious. I mean, it was obvious that this is gonna happen, but if I print here 4, what's gonna happen now? The same. Yeah, because even though we just call minus and then take value, but yeah, value is no. Okay. Yeah, this works because dummy print here actually didn't move 4. It moved only the value, value of that, and then here we could use just print 4, and then all the subsequent calls failed. But yeah. Yeah, that, I mean, maybe I'm making wrong conclusion, but I think that's the case. So the following line will pass because 4 is not moved in the set spell. Okay, but then this is gonna fail because I moved 4 here, but I won't just invert the mutable 4 type and then print the value again. Boom. Okay. And print number is now, and since I've never moved actual value, I think I should be, yeah, again the same. So I should print number here 4. This should work, and now I shouldn't have the dead code from before. Yeah. All right. Okay, I have a comment I haven't noticed before. Statue.net just stopping in. but looking forward to watching the recording later. Cheers. Great. Yeah, okay. Amazing. Yeah, feel free to watch. This is going to take. Feel free to watch at any point. That's why these streams are cool, since I can record and then you can watch immediately after or whenever. I think this is pretty cool. Okay. We passed that. I think we did that. Yes, and then let's make the clone. So far we can move and we can reference, but copying is also nice in general. So let's go back here. Print number. So we will implement std clone for number. Okay. Fn clone ref self. Clone takes a reference and returns self. So self in this case is a number, so the number is going to be returned, and then self then self is created by, that's again like pattern. I don't know how to call that. Let pattern, like similar to let pattern, just a new self will be returned. And I think the star here is just to do dereference. Yeah, why is the star here? I don't know. Self this. Why is that so? I'm not sure. I don't understand the star here. No. Maybe the simpler way is just to do this. Expected struct found. Yeah. Self is some kind of dereferencing, because we need to get exact number. So yeah, okay. I think it's that. Maybe it has some hidden behavior as well, but yeah, for now let's live with that. When invoking trait methods and the receiver is borrowed implicitly. Number? There is a clone and copy. This is now getting a bit cryptic. So trait methods can also take self by reference or mutable reference. Okay. What's the difference between clone and copy? Clone is so I'm getting a mutable m out of n, and I can mutate it here, and then I'm taking reference. Understood. In the copy case, note copy requires that clone is implemented too. Now clone can still be used, okay, but number values will no longer be moved. So number m is a copy of n. If copy is implemented, then copy will be if copy is specified, then the clone will be used to copy that into a variable. Okay. And how to know that? Let me just put here print line clone of making a clone of this self.value. Yeah, this is obviously not very good from the coding standards, but I just want to be sure what is going on. So clone is not explicitly, is not called, but if I do implement std marker copy for number, still nothing since I don't assign stuff, but let's do let's say v no v for copy. That's gonna fail because of what? Why is this possible since I moved this 4 here? And why I didn't get clone? Why is that possible now? Since I get value, fine, print number. So this should move. No. Here, because we implemented the copy, here is copy is also done. But why we don't have print number? Why we don't have that printed out? I think I understand. So print number, I don't understand why it's not printed, but if I comment this line here, it should start behaving nor yes, okay? Values here after move, which is obviously true, but if I do here, it's gonna make copies. So here, it's gonna make a copy of 4. And then here, it's gonna make a copy again. So this should essentially make 2 copies, but why is not that printed in the terminal? No idea. Okay. And why is this? What about, what if I do here? I really don't understand why I can't copy. Maybe that's some kind of recursion or something, since I'm accessing, but shouldn't be. Since I'm not cloning here, I'm having a reference and I'm using that reference. So, what if I just do basic? So print ln test. Sorry. Nope. Maybe to ask more. Track. What is that? Okay, let's not waste time here. I think that's the case, but I don't understand why the print method doesn't work here. So I will leave it as is. And this is now changed. Probably some of the above. The following line will pass because 4 is not moved in the previous line if the number has, how to correctly set that, number has the marker trait copy, find the print number will always pass. Let's put it like that. Okay. Okay. No longer be moved. Yeah. Some traits are so common they can be implemented by using derive attribute. Attribute is obviously marked with hash and then put into these braces. Instead of using clone and copy, we can just put derive. Yeah, okay. Functions can be generic. Okay, generic. We did that with dummy. They can have multiple type parameters. Yeah. That's fine. I'm not gonna do that. Usually have constraints, so you can actually do something with them. Okay, display the simplest constraints are just three names. I already put that. I already did that because compiler warned me about that. Obviously display is visible in the just answer here. Okay. Display. So yeah, this is probably so T has to be displayable. So T has to be some value that the default formatter is implemented or something like that. And what's debug? Debug. This is like a syntactic sugar for doing where T display. It can be more complicated. They can require a type parameter to implement multiple traits. T debug plus what is a debug? Have I missed that? This is also in formatter, so it's kinda. But what if I put here debug as a trait? X. I need a display. What's the difference between? Anyway, I think I'm gonna figure out this here. Yes. Debug. Debug should format the output in the programmer facing debugging context. Generally speaking, you should just derive a debug implementation when used with the alternative. Aha. Hashtag exclamation mark. No. If I use same. Okay. What if I just remove? Doesn't implement. Aha. X. Not quite. Which was 6. Mm-hmm. Yeah, but it's still not written in the. What if I derive debug? Nothing. Dummy print. Aha. Since I have copy, I should be able to print. Required by this bound in dummy print. Aha. Manually implement display. No. What if I just say here a display as well? So display has to be implemented. Formatter. Can't be derived. Formatter display 4 point. I'll use I'll try to use this as an implementation for the number. Number. Imapala. Set the format std fmt fmt self formatter self dot write f. Okay. Self dot odd self dot value. Let's leave it like that. If I run this, that's all. Number std okay. Finally, so we have number. And now now we have a debug print of that, and if we change so here, if we do just like this, it's gonna be display. Yes, okay. Okay, great. So this is this is a display print. Yeah, now it's a debug print, and this is a display print. Okay, let's leave it like that. Great. That plus is probably means like a union of these two, like both, or both, any, or no, probably both, because if we remove one, then it doesn't work anymore. So for example, if I just comment this, it's gonna scream. Yeah, nice. Okay, generic functions can be thought of as namespace containing an infinite. Yep, some as it creates and modules and type. Yep, okay. Prints use type name. Type name. It will just. Okay. This is call it. Looks like fish. Haha. Okay. Turbo fish syntax. Okay. Basically, by doing that, we just print. So print ln. If we do like this, and then std any type name f64 char Okay. Structs can be generic too. Okay. Obviously, if I do so now, I print type name t, value reference. I take reference to t. It prints the type name. Oh yeah, that's a useful function to have in the arsenal. Let's put it here on the top level. Print type name t val t any type t. Okay. And if I do print type name, let's say print type name or for copy. Nice. So the type is actually the so the Rust doesn't like these minuses. He likes underscores. Okay. And then number. But if I do, what if I change a value of a number to be let's say t. This might explode. Boom. Yeah. No. Rollback. Since not gonna fly, I'll create another pair t. Pair. So pair is now pair of two types, and then print type name. So let p1 equals pair of a 1.0, b 2.0, and if I print p1, it should say like a float something. Yeah, pair of f64. That code, okay. Okay. Don't worry, be happy. We're gonna use that at some point. Okay. Good. The standard library type vector, a heap allocated array, is generic. Yes, since that's the standard thing, since you want these arrays to store any value, any type. So a vector push1 what's gonna happen if I do this? So what's gonna happen? Obviously v1, we have v1 already but should work fine. And then I push 1, and then I push false into v1. Yep, so it obviously uses the first value, and if we change and we do 1, yep, not gonna fly. Yeah, it uses the first instantiation, actually not that, like the first call of a push method, it used that to determine a type that has to be preserved all the time, which is also nice, since you can do whatever, and then compiler will warn you yeah, compiler is gonna warn you when you are doing crazy stuff. This should work. Okay. Okay, great. Speaking of vector, it comes with a macro that gives more or less. This is a macro. So obviously these exclamation marks are representing macros. All of name, invoke a macro. Macro just expand to regular code. Yeah. In fact, yeah. Macro, yeah. And that will expand, that will create a vector of these things. So let me just do one of these. But it probably has a debug. Nope. But it needs to have not gonna fly. So print type name, Okay. Macro, yeah, I'm not sure how are you familiar with macros, but basically these macros are different things in different programming language. For example, in C, that's a pretty basic concept. Basically, these macros are just are replacements. So the macro is replaced with the code. But in some other languages, like for example Lisp, these macros are more powerful. They are actually getting executed, and yeah, I assume Rust is. I mean, people say Rust is very good. Macros in Rust are very good. So yeah, we're gonna probably come to that later. That has the same effect as std yourself, right? Okay. std. So println is actually doing this. So std out, take a lock, write all these bytes, and then unwrap the result, probably the return value. Panic is also a macro. It violently stops execution with an error message and the file name. Okay. Panic. So if we do panic, if we go into panic mode, not good. Usually we shouldn't go into panic mode. Avoid that at all cost. Main thread panicked. Yeah. Okay. Let me just check this unwrap. Rust unwrap option, and in the last example, la 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 la. Ah, option might have a value or not a value at all, and then unwrap returns a panic when it receives a none. Aha, okay, makes sense. So, and what is sum? Sum t gift. Oh shit, it's editable. An element of type t was found. Aha, sum actually creates an option of that, and then sum is like a sum is just, if I understood correctly, sum is just a function that creates an option. It's not option, is enum of none and sum. Enum. Okay, but I think I understand. So if you want to create, in this case here, you got back an option and you unwrap. And if the value is not, it's gonna panic. If the value is something, it's gonna be returned. Actually, this is like semicolon, so it's not gonna be returned. It's gonna be just evaluated, and that's it. Some methods are also panic. For example, option type can contain something or can contain nothing if unwrap is called on it. La 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 la. Option, some, none. Okay. Okay, option is not struct. It's an enum with two variants. Okay. Enum unwrap. Yeah. So self sum. Yeah. So this is a bit more. So it has option has a type t, and unwrap returns exactly t. Match self, that's like value. Self sum t. If value is there, return t. Non panic. Option non sum. La la la. Okay. Result is also an enum. It can either contain something or an error. Okay. Result is result can have result has two types, T and E. E is obviously an error, and T is like the value which is legit. Variables bindings have a lifetime. Wasn't that there before? Like that's the same code. Yeah, okay. References have a lifetime. Ref starts existing, it borrows X. Yep. No, X no longer. Yeah, okay. A lifetime. The lifetime of a reference cannot exceed the lifetime of the variable binding it borrows. Yeah, that also makes sense. So you take X. X exists only here, and then you reference it, which is fine in this context, but in this context it's not anymore. Nice. A variable binding can be mutable, borrowed multiple times. Yeah, that's correct. While borrowed, a variable binding cannot be mutated. What's that? So X, and if you take X ref, X is 13. So basically what it says here is that if you take a reference to a mutable variable, you can't mutate that value, which makes sense because, and that's why the wording is borrowed, because you have a reference to that, and if you change it, I mean, it's not that you can't do that, but in theory, but the problem is you're gonna get, if the mutation is allowed, you're gonna get two different values out of the same call before and after X is mutated. While immutably borrowed, a variable cannot be mutably borrowed. Whew. Okay, if you have X and you take immutable reference, you can't take immutable reference. If you can't take mutable reference, which is also, I think, fine, but yeah, it's a restriction on what you can do. References in functions argument also have lifetimes. X is borrowed from the outside for the entire time the function is called. Okay. Functions with reference arguments. Functions with reference arguments can be called with borrows that have different lifetimes. So lifetimes are generic parameters. Okay, this is something new. Function with reference arguments can be called with borrows that have different lifetimes. So all functions that take references as generic lifetimes are generic parameters. Lifetimes names start with a single quote. Elated, non-named lifetimes. Okay. Okay. This allows returning a reference was lifetime depend of the argument. Struct number value blah number value return a reference to the value. All right, and then we borrows n immutably, thus we cannot outlive n. Okay, while we exists, n cannot be mutably borrowed. I don't understand this. So you specify here like multiple things. So you specify a, which is a type. There is a single input lifetime. It doesn't need to be named. I don't understand what's the purpose of this. This allows returning references whose lifetime depend on the lifetime of arguments. Okay, like lifetime. So argument is here dependent on this, and you can return this. Okay, so here we return value here. This is just like a syntax for specifying that this reference is taken to the value, and that while that's true, while you're holding that we think you shouldn't borrow, mutate, or move. Yeah, I think I understand now. And that's single input lifetime. If you have one of these, you can ignore that. Structs can also be generic over lifetimes, which allows them to hold references. Okay. This is a reference to something. That's the same, but just you can hold like that xref. Okay, the same code but with additional function. As number f. Okay. Yeah, this now escalated quickly with these references. I think I understand the concept, but yeah, these are just different examples. Let me just check. So here we are like on the 2/3 of the whole thing. So we are returning these references. That's all about these references. Strings literals are static. Now we have static as well. Okay. stuff. Yeah, still has a bunch of stuff here. Yeah, let's play with this. Okay, that's the same. We can have a numref. Okay, C code, but with additional function. Let me just take this. So here we have a reference to that integer, and we create that so let x be I32 99. Okay, and then let x ref as numref. Okay, makes sense. And now we have a reference to that number, and we can print number. Let's do it like that. Xref, that's gonna fail 100% because we have a reference. What? Yeah. Expect number found. Ref.x. Expected struct number. 99. Okay. But we have a reference to that 99. And what if, let's say that I make this mutable and I want to call here, this shouldn't be possible. So let's say dummy print at x dot, no, x equals to 100. So that shouldn't be possible. Yes, because yeah. Basically this is just a syntax to prevent that. But what if why I need that? So for example, why I shouldn't be able to do this t. This is a lifetime argument. And A stands for argument. If I replace it with A, it's to me. Okay, obviously I can have, yeah. Okay, let's ignore it here. Yeah, obviously, I don't know why the convention is to use a small, because okay, obviously, like a is a lifetime argument, but why it's written in a lowercase letter I don't understand. But any case, so a is a lifetime argument. And now it makes sense. So I take that type, and then, but why I need here, what if I remove this? This is actually not templated, so it just uses lifetimes are generic parameters. So you have, so this is used, but what if I say here t, and I say hey t as well? This should be a generic one. So I've just specified that this is a lifetime argument, and then I have t, and t is whatever. Something like this should work. Yeah. So now I have a generic ref. Previously it was it was just a regular struct with E32, so I32. So yeah. Okay. I think I understand. So for these lifetimes, you need additional template, like for the lifetime stuff. You need an additional. Okay. I think I understand now. So you need to specify that lifetime type of thing, which is kind of cryptic, but yeah, one can survive. Numref, yeah. Now that makes sense. Now that makes sense as well. Elated life is, so